requires that you be in the general edit mode in the property filter, which I'll show you, and then you can basically select a window around vias or pins that you wish to replace, and then a right mouse button will give you the actual option to replace those. So we'll be showing that. The next one in that group is a skill routine, which will allow you to change nets on vias. These skill applications, there are some sample ones that are supplied with your installation of your tool. The current directory path is what's shown here on the screen. So it's in the Share PCB Examples skill, and it's in a folder called CMD. So this is in your current installation of where your tool is installed. So if it's on the C drive, it would be C, Cadence, SPB, 16.5, and then the Share path that you see here. To invoke the command, it's actually just something you type on the command line in the command window, which I'll show you how to do that. And then simply window around the vias and then select the new net that you wish to change them to. This works very well because it doesn't matter if these vias go down through multiple planes and you decide to change them to another layer. It's a very powerful tool to do that. Next slide is a thing called ZCopy. So ZCopy is a very powerful utility that you can use to make multiple copies simultaneous through the Z-axis of the stack-up. And what's nice about this is you can copy the net names. So if I have multiple ground layers, which I do in this case, I'm going to copy those net names to those copies that I'm creating. And I can use a wildcards, which means if I have 4 or 5 ground layers that I want to copy this information to, I can do it in basically one keystroke. Next item is what we call data tip customization. And this is a user configurable data tip display. You can display property name, value, or both. The settings are located in your PCB ENV directory, and it's contained in a configuration file called customdatatips.cdt. So whenever you make changes to these settings in this panel, it writes it to this file right here in your PCB ENV file. So with that, let's go ahead and take a look at the actual tool. And let's look at the first feature. So this is replacing pins or vias by window selection. And the way I do that is I go to this general edit mode here in the upper left. If I select that, that tailors my fine filter, for specific items that I want. So in this case, I have pins selected because I want to replace these particular pins. So if I select those, it now highlights. I can right mouse click and I can say I want to replace these selected instances. Now it brings up my library path to my pad stack library, and I'm just going to use my filter here. So if I do an SO24 star, it kind of sorts out the ones that I'm looking for, and I'm going to replace that with an oblong pad. So very quick and easy way to to change those. Now changing net names on vias, which is the next selection. To do that, I'm going to turn on the command window. So I go to View, Windows Command, and I get a prompt down here. And I just simply, type the command now to change, the net vias that I want to change. However, I want to give you a little background. If I open up my file here, the way you run skill scripts is in your PCB ENV folder. There's a file called allegro.ilinit, and what this file is whenever you launch the tool, this initialization file gets run, and all I'm doing is I'm pointing a path to that skill script. So this, when I launch the tool, it looks at this file and it loads this particular skill script, and that's what enables me to invoke them in the PCB editor. So now if I go down here on the command prompt and I type change via net. And now I can just swipe a window around the vias that I want to change, and now it prompts me with a new net name. So I can just select the net name from the list, and now I've just changed all of those vias that I selected all the way through the board. So if there were multiple planes that they were connected to, I've now just easily changed those. The next thing is let's show you the ZCopy command. So I'm going to do a fit view here. And I'm going to go and I'm going to turn on my visibility here. Oops. And what I want to do is show you this is the layer that I wish to copy. So there's several split planes here. And if I go down through the stack up here, you'll see I have a ground 8, I have a ground 11, and so forth. So all of these layers are currently undefined, and these are the target layers. So what I want to do is I want to take all of this copper information as well as the net name and so forth, and I want to propagate it down through the Z-axis using ZCopy. So I use the ZCopy command. If I go to my options now, and I want to copy the net name, my target layer, I'm going to start off with my ground 5, but here I'm going to use a wildcard. So if I put in a wildcard or an asterisk, this will now allow me to copy to any layer name that has this GND underscore prefix. So all I have to do now is simply tag those areas, and now I've copied it. So let's take a look. So you can see, let's see. Okay, let me try that again. So I'm going to ZCopy. I'm going to create a dynamic shape. I forgot to check that. That's what it was. And I'll just simply tag it. And now it should be fine. So if I go to my panel here and then toggle my visibility, I should see the replicated ground layer now. So as you can see, pretty powerful command. I can easily propagate that down through my stack up. Okay, so the next thing I'd like to show is data type customization. So let's zoom into an area of the board. And if I go to my general edit again, and what I want to do is I want to simply hover over and go into my fine filter, and I'm going to select net because that's what I'm interested in this case. So you can see this little data tip that pops up. So as I hover over net, I can get whatever custom information that I want to be displayed on that data tip. So the way that I do that is I go to Setup, Data Tip Customization, and in this case I'm using net information, but you can search on any of these objects in the database, and then you can select names and values of things that you want to display. So in my case, I'm showing the length property for that particular routed trace. And again, these are stored in that file in your PCB ENV file. Okay. So I'm going to hop back to the slides here. The next thing I'm going to talk about is a thing called how to suppress pin-to-pin violations within the same symbol of a part. So this is very handy. Like if you have a lot of fine-pitched devices where you have a pin-to-pin DRC that's showing because they're very close together. However, it's something less than what your design rules are. What you can do is you can set a property called no DRC same pin, same symbol pin, and you can apply it to the symbol. Well, that's that's very well and good, but it only applies to that particular symbol. So what if we have a lot of these on a board? So we can apply it to the entire drawing, and it has a global impact. So again, this is kind of a nice thing we can do here. We can also automate this in a way where we can create shortcuts using scripts. So if I enter script mode on my command line, so I enter this command called script mode +E in the command window, this will echo all of the commands that I apply in the editor, and then I can map that to a function key and then execute it with a keystroke. So let's take a look at that. So if I do, let me zoom up to this area, and I'm going to turn on my top DRC. So you see I have a lot of, pin-to-pin violations here. If I do an edit properties, and actually before I do that, let's just go ahead and launch my script mode. So I'm typing on the command line, script mode space +E, and now that will record all of my actions. So if I do an edit properties, and I go to my find filter, and I go to symbols, I want to do a drawing type, and if I hit more, it gives me now, I'm going to apply it to this drawing. So this, now shows me what's currently set. And what I want to do is the property that I'm looking for is this no DRC same pin to pin. And if I apply that now, so it's over here, and it's set to true. So if I apply that now, I've now just applied it to the whole drawing. So now those same pin DRCs have gone away. Now, that was several steps to perform that action, right? So what I can do is, if this is something that I use all the time, what I can do is I can capture what was in this command window, and I can apply it to my ENV file, and my ENV file will allow me to automate that. So let's take a look at my ENV file. So this is the actual command. So I'm assigning it to a function key called E, just the letter E on my keyboard. And these are all of those commands that have been captured now. They're simply separated. Each command is separated by a semicolon. And I just, concatenate those on that single line. And now this is saved in my ENV file. And now I can execute that with a hotkey. So let's go back to my PCB editor. I'm just going to hit my E key. And now you can see I've repeated everything that I just did in a single keystroke. So now if I decide I want to remove that or set it to true, I can do that. And I did something wrong because it threw me out. So let me just relaunch here. Okay, so the next, let's go to the next section. The next section is going to be covering how we can add text from a file on disk. So this could be very handy if you wanted to add information to your fabrication drawing or something, or if you wanted to add maybe some bill of material information that was created from the schematic, or those sorts of things. Any kind of text that you would like to include in a drawing. And you simply do it by adding the text command. You set your desired text options in the control panel, size and so forth, and the rotation. And then we simply just position the cursor where we want to place it, and then a right mouse click will allow me to read from a file. The next tip is there are times when I want to be able to save the current board that I'm working on, but I want to save it to a new name. And if I save it just as a file save as, or file save and change the name, what happens is whatever name that I give that now becomes the board that I'm working on. Well, I don't necessarily want to save another copy. I want to keep working on the current drawing, but I want to, save it to a different name. So using the write command in the command window will enable me to do that. So in this case, I want to write a database called backup, and I just simply say write backup, and it'll create a new database called backup.brd, and it'll still preserve, whatever name of the database that I was currently working on remains the same. The next item is talking about file management and how you can manage your artwork, your plots, your log files, your reports. So what you can do is you can set up distinctive folders for these items so that they don't kind of clutter up your design directory. So let's go ahead and take a look at these items. So if I go back to my board, and I'm going to zoom out here. And first thing I want to do is, be able to add some of my notes that I wanted to this database. So I just simply go here and add text. I position the cursor where I want, and I say read from file, and I can go out here. So in this case, I have a manufacturing BOM that I want to include, and now it gives me the ability to add that to my database. And under your options, of course, you can pick whatever layer that you want to add that to. So I probably should have added it actually. So I'll do the undo. Let me do it one more time. Actually, probably want to add it to my under my board geometry information, and I'll probably put it under my assembly notes. Again, if I want to save, so right now my database is called tipsandtricks.brd. However, I want to save this, and I don't really want to overwrite that. So I can just save it to a new name saying write, and I'll just call it backup. So now you can see down in my command window, I've written a new database called backup.brd, and I've still preserved the one that I'm working on. So that's the difference between the write command and the save command. The next item is talking about the user preferences. So if I go to user preferences and I go to my file management, if I go to my output directory folder, I've set some folder names here of where I want these various items. So when I set these names, when I close this form, this gets written to my env file, and that's what implements this. If I go to my Tools, Utilities, File Manager, I'm in my actual project directory now, and you can see those are those folders there. So any reports or anything that I run, that's where they'll be displayed. So kind of a nice thing, gives you some organizational capability to kind of keep all your things together in an orderly manner so you can find them. Let's go back to the slides for a minute. The next thing we want to talk about is differential pair routing. So differential pairs are defined in the constraint manager. We would first set up a rule, and then once we set up the actual differential pair rule, then we would go and apply that to various nets. So this is just a screenshot of that. We can also control the gather control. So this is normally how the differential pair would be routed, but there's a pad entry factor, and this is in the user preferences. So we can set the pad entry factor, and if we can change these numbers, we can change the behavior of how it exits the pins coming out of the device. So let's take a look at that. Oh, and one more thing. We can also route tandem differential pairs. So if you have what they call broadside or tandem, where the differential pair is actually being routed, there's the other half of the differential pair is one layer below or one layer above in the stack up. The dielectric really becomes the gap of the differential pair, if you will, since they're on top of one another. And to do this, you simply have to just stub out each end on the layer, the particular layer that you're going to route the tandem pair on, and then these will route as one differential pair. So let's take a look at that. So the first thing I'm going to do is open up my constraint manager. And if I go under my electrical domain, I go to my differential pair rule. So this is actually where I define it. So here's my maximum uncoupled length I'm going to allow. Here's my minimum line spacing. Here's my primary gap of my differential pair, as well as the primary width of the differential pair. So the spacing is 6 mils in this case. The primary width of the differential pair is 4 mils. Once I've defined the rule, I come down to the netlist section and I go to differential pair, and then you can see this referenced electrical rule called diff is applied to those diff pairs. Now if I expand them, these are the two nets that make up that differential pair, and here are all of those rules now that have been applied by referencing that rule. So let's take a look. So if I zoom down into this area of the board and I swipe my add connection, I can just grab those wires, and you can see, if I zoom in here, you can see the differential pair automatically gathers to that 6 mil gap with a 4 mil trace width based on my parameters that I have set up in my constraint manager. So let's take a look at changing the pad entry factor. So if I go to my user preferences, and you can search down here too. So if I say pad entry factor, I can change this value. So if I change this to 10 and I apply that, I can change the behavior of the diff pair and how it exits those pins. So here you can see I have a much tighter control now. So you can see I have a much tighter control exiting those pins now. And if I want to route a tandem differential pair, here I just have each layer stubbed out. So this is on, in this particular case, on layer 3, and the other half of the differential pair is on layer 4. So just by stubbing them out and placing them over top of one another, you can see I have two flight lines now on my cursor, which shows that I'm routing the differential pair. So there's the layer above, and if I turn that off, you can see there's the layer below. So the dielectric is actually achieving the gap like I did on this one, only it's broadside. So next item is talking about ISRs. So ISRs are very important. They come out about every 2 weeks. It's not necessary for you to go out and hunt these down every 2 weeks when they come out. However, they do fix issues among all the tools. They're not limited to PCB Editor. So when this ISR comes out, the ISR includes all of the tool sets, whether you have Capture or Allegro or OrCAD or the PCB SI tools. So these updates, when they come out, encompass all of the tools. They come out about every 2 weeks. They can be downloaded from our ERC site. And occasionally, in addition to fixing items in the ISR, they also add additional functionality. So in this particular case, there was a new feature that was added in ISR number 7, which has been out for some time now. But this ability allows you to taper traces and add what we call fillets or teardropping. So this is very useful. So here's an example of where I have a trace exiting a via from a BGA pad. And normally, if I didn't have this teardropped, I would have just this line entering this pad at a 90-degree angle. Well, when we have very fine line boards where this might be a 3 or 4 mil trace, it becomes somewhat of a reliability issue because this could be a fracture point where the trace enters the pad. So by teardropping this, I'm adding additional copper, and what that does is it increases the reliability of the board and prevents that from happening. The tapered trace allows me to taper from one width to another and do a very smooth transition. So this is the dialog box. This feature used to only be available in the higher levels of the tool, but I can do teardropping or these tapered traces, and here are all the options and all the different pad types and so forth where I can adjust to get the desired effect. So let's take a look. So I'm going to zoom up to an area of the board here. And here I have some of those tapered traces. And here I'll just eliminate my DRCs since my database closed on me earlier. I just used my hotkey. And what I'm going to do now is I'm going to go under my gloss menu, because that's where this is. If I go into my fillet parameters, this is the new fillet and tapered trace dialog. So I can adjust all the parameters. I have some settings in here that I'm going to use for the demonstration. If I simply so what I want to do now is execute it. So if I go to route gloss and I say I want to add a tapered trace, I simply just swipe a window around that now. And now you can see, if I zoom in here, it uses a shape to accomplish that. So you can see I have a very smooth transition to do that now. It also works very nicely if I wanted to add teardropping or fillets down here. This is the behavior that you would get coming out of a pad. So you can see I took that 90-degree very thin trace entering this pad, and I've just now added additional copper to improve the reliability of that. So what I'd like to do is also talk about some apps now. And we now have a OrCAD Capture Marketplace where you can download apps for both PCB Editor as well as OrCAD Capture. And the direct link is here, but if you have 16.5 with ISR 7 or later, you'll actually see a new start menu, which actually launches a start page. In fact, maybe I can show that to you very quickly here. So if I open up Capture and I'm in 16.5, this new start page is kind of nice because it tells you your current release. So this is a live connection to the internet, so it's checking my current release against what's available. And this start page now I can launch a design or a project from here, as well as get into my documentation and tutorial, but also get you to the live EMA support page. So upcoming events are announced here, any specials that we might be having. Here's some what's new, and then if I click on here, that actually takes me directly to the marketplace. If you don't launch it in Capture, then you can use this link right here through any web browser, and that will take you directly to the marketplace. So I'd like to open up for another poll question and just ask folks what topics would you like to see covered in a future webinar. So the polls are open, go ahead and please leave your comments. That would be appreciated. And then I think after the poll question, we'll probably be opening it back up for any kind of live Q&A. And polls are still, okay, the polls just closed. And I'm going to turn it back over to Kelly for some Q&A.
Okay, thanks, Rocco. If anyone still has a question, if you could raise your hand on the dashboard and we will unmute you and you can ask it directly to Rocco. So we'll wait for a moment and see if anybody has a question. Okay, I see one. Mark Melville, you are just now unmuted. You can go ahead and ask Rocco your question.
Yeah, you had shown us how to insert text with from a file.
Yeah.
How do you insert like pictures from a file? Is that a similar process?
It's not done as directly as the text, but what you can do is there are some utilities out there. For example, there's one out there that I found, and you can find these, on the internet. Is you can take like a bitmap or a JPEG, and it'll convert it to a plot file, and then I can read that in directly. That's one way. Another way is if you take, say, an item, maybe it's a logo or something like that, and it was generated in a mechanical tool or something like that, maybe the company logo, very fancy, logo. What you can do is write that to a DXF file, and then import that DXF file, and then what I've done is made them a part, so I can load that logo onto my board as a library part.
Okay.
So that's probably the easiest way to do it.
Okay, thank you.
Okay.
Okay, are there any other questions? We have one here. Ed Hitt, I have unmuted you. You can go ahead and ask your question.
Go ahead,
Ed, are
Ed.
you there? Okay, looks like his microphone must not be working. We do have a couple of questions on, Ed doesn't have a microphone, but he did ask a question online, so I'll read that. He said he's running PCB Editor 16.5. It has the latest version. However, when I go into the route menu, I don't see the gloss menu pictures, just demonstrated for teardrops and tapers. How can you make sure you have ISR 7?
Yes, two things. That particular feature is going to be an ISR 7 and higher, so make sure you have the current ISR at least 7 or higher. We're currently up to 18, so it's been out there for a while. And the other thing is that feature is only in OrCAD Pro and higher. So if you have OrCAD Standard, the teardropping is not going to be there for you. So OrCAD Standard would be, the very basic entry package. But it will be in under your route gloss menu is where you will see it.
Okay, thanks, Rocco. All right, any other raised hands here? I don't see any. There are a couple other questions online that I will ask. Let's see. How can I prevent DRC errors caused by the fillet command?
How can you prevent DRC errors caused by the fillet command? I guess I need to know more information. Are they with adjacent objects, or can you elaborate more? Is that person online, or that was one of the text questions?
Yep, and maybe he will. Oh, we have one more question online here. James Van Eaton, you can go ahead and ask your question.
Yeah, I had a question about the text file you imported.
Yes.
What type of file was that? Was that an Excel spreadsheet, or was it a text file? How was that formatted?
It was just a plain text file.
Okay.
Just a raw text file. In fact, I can probably bring it up here for you. So it's actually this one right here. So it's just plain text. If I open up in a text editor, that's all there is. So that's exactly what it is.
Okay, and that capability will apply only to text files, not any other sort of application?
Yeah, it's strictly text files. So
okay.
I mean, I'm not going to be able to import like an Excel or something like that.
All right.
Because it's a different file format. Okay.
Thanks.
Okay, and this is the last call for any other questions online. Mike Finnerty, you can go ahead and ask your question.
Hey, Mike, go ahead.
Okay.
Are we there, Mike?
He may be unmuting. Well, can you go ahead and tell them, Rocco, how they can download the newest ISR? There's a couple of those questions.
Okay.
Rocco?
Oh, sorry. So if you go to the ema-eda.com website, under the support section, that'll take you to the main ERC menu, and you log in there, and then you can download all of the updates and ISRs, as well as these tips and tricks document is going to be posted there next week.
Okay. Tom Tucker, do you still have a question? You can go ahead and ask it.
Yeah, Rocco, does the differential routing constraint, does that apply to all versions of the PCB editor?
Differential pair support is going to be an OrCAD Pro and higher. Okay. So if you have OrCAD Standard, then differential pairs are not going to be in there. So OrCAD, and maybe I can spend a minute on the differences between OrCAD Standard and OrCAD Pro. So OrCAD Pro comes with, like I said, differential pair support. It also has some limited etch length control, so you have like a min and a max etch length that you can control. It also has the glossing, or the teardropping and tapered traces. It also has constrained regions, and it also has placement replication. So if you have other common circuits or a common power supply that you wish to use on another design, you can save those off and then reuse those. So that's going to be an OrCAD Pro as well. And then OrCAD Pro also comes with a 6-signal shape-based auto router as part of the bundle, which means that you can have up to 6 routing layers, but you can then have unlimited plane layers. So it's not limited, only by 6-signal routing layers. And if you need to go beyond that, you can add an option, to go to the full-blown, 256.
So the standard just comes with 6 signal routing layers?
Yeah, 6 signal routing layers, correct.
And
that's
Pro
going to be an
OrCAD
OrCAD Pro.
How many
no, OrCAD Pro? Yeah, OrCAD Pro comes with 6, a 6-signal version of the router. And if you need to go beyond that, you can add that option of 256, which opens it up to full 256 layers.
Because I rarely have a board that's less than 6 routing layers these days.
Oh, some people do. Like I said, you can have unlimited plane layers. So you can have 6 routing layers and 6 plane layers, which would give you a 12-layer board.
Yeah, I do a lot of 16, 24 layer boards.
Okay, yeah, so then you're going to need something beyond that. So you would need to have that 256 option then.
And that's not just with Pro, that's an option to the Pro.
That's an option.
Because the Pro comes with
okay.
6 signal, and then you have to upgrade that to get the more layers.
To the 256, yeah.
Yeah, okay. Thank you.
Okay, Gary Daniels, you can go ahead and ask your question. Do you have a microphone?
Yes, I think you already answered it. You typed back.
Oh, okay.
Thanks anyway.
Okay.
Okay, well, it looks like we don't have any other questions, so thank you very much for your time. And again, just as a reminder, the webinar will be posted to EMA's webinar page coming up probably on Monday. You can check back to our website and you'll be able to watch the recorded version. There are a few questions still coming through online, and we will stand by and answer those. Thank you very much.
Thank you.
Thank you all.
Thank you.